Hi again! In the previous lecture, we created a linear regression model using sklearn. The output we got was this line here. To be true to myself, I feel we should elaborate on these parameters. All of the parameters you see take the default values set by the module. I'll start from the last one, as it probably is the vaguest for you. Standardization was the process of subtracting the mean and dividing by the standard deviation. In fact, standardization is a type of normalization, and sometimes the two terms are used interchangeably. Personally, I don't really like the term normalization, as it always needs further clarification. In this case, normalization means we subtract the mean. This time, though, we divide by the L2 norm of the inputs. You can check the article following this lesson if you'd like to learn more about that. Instead, let's focus on another parameter, copy x. When it is set to true, it copies the inputs before fitting them. This is a safety net against normalization and other transformations that can be done by sklearn while creating an algorithm. If you remember, in our StatsModels lectures, we would create copies of data frames every now and then. sklearn takes care of that automatically. Okay. Then there is an argument fit_intercept, which equals true. In StatsModels, we had to manually add a constant. The fit_intercept parameter takes care precisely of that. If you don't want an intercept, you can just set it to false. Finally, njobs is a parameter used when we want to parallelize routines. By default, only one CPU is used. For this simple example, we won't see a difference no matter the number of jobs we set. However, if you work on problems with lots and lots of data and have more than one CPU available, you can take advantage of this parameter by setting it to 2, 3, 5, and so on. This short discussion exhausts all the parameters. Let's get back to the statistical side of the regression. We will start with the r-squared. To get the r-squared of a linear regression with sklearn, we use the method score. reg.score x matrix y. The result is 0.406, exactly the same as the one we found with StatsModels. What else do we want? The coefficients and the intercept, right? The coefficients are found with the following command, reg.coef_. The result is an ND array containing all coefficients. In this case, there is a single value, 0.0017. When we get to the multiple regression lectures, this array will be filled with the coefficients of each of the features. Can you guess the code needed to obtain the intercept? reg.intercept_. This time, we've got a float instead of an array. That's because this type of regression always has a single intercept. All right, we've covered most of the basics. Finally, let's see how we can predict GPA using the SAT score. There is a dedicated method called predict, which we can take advantage of. Predict takes us arguments, the inputs we want to predict, and outputs the predictions according to the model. For instance, reg.predict1740 will give us the predicted GPA for an SAT score of 1740. The result is 3.16. As you can notice, this result is also an array, not a float. That's because the predict method can take more than a single value. In fact, it can take a data frame or an array. Let's try this feature out and predict some more values. I'll create a new data frame called new data. It will be a pandas data frame with data 1740 and 1760 and a column name SAT. That's what's contained inside. Using the reg predict method, we can feed the whole data frame, new data. The result is an array with the two predictions, 3.16 and 3.19. Great! If you want, you can even add this information directly into the original data frame. So, new data predicted GPA equals reg.predict new data. This will create a new series in the data frame containing the predictions of the model. Good job, everyone! Finally, we can plot the regression using the same code as before. So, we have successfully created our first regression with sklearn. The default methods give us much less information, but much more capabilities in the long run. Stick around, and we will learn more of the sklearn syntax together. Thanks for watching.